All right, let's talk about something you probably handle every single day. Something so common, we barely even notice it anymore. Salt. But trust me, the story of how this humble mineral gets to your table is anything but ordinary.
I mean, just look at it. You know the one I'm talking about. That simple shaker filled with tiny white crystals. It's got to be the most basic, most fundamental seasoning on the entire planet. We just sprinkle it on our food without a second thought.
But really, have you ever just stopped and wondered where it actually comes from? Or how it's even made? Because that simple little shaker holds a massive story of deep geology, mind-bending chemistry, and literally thousands of years of human ingenuity.
So to really get this, we have to go all the way back to the beginning, back to nature's own original recipe for salt.
Okay, so the most obvious source, right? The ocean. Seawater is packed with the stuff. But here's the kicker. A huge chunk of the world's salt actually comes from these gigantic underground deposits left behind by ancient seas that evaporated millions and millions of years ago.
And to give you an idea of just how salty the ocean is, get this, every single liter of seawater contains about 35 grams of dissolved salts. Just let that sink in. That is an incredible amount of flavor just floating around out there.
And do you know that rock salt I was just talking about? Well, it has an official mineral name, halite. So whenever you hear about giant salt mines, this is what they're digging for. Solid crystals of sodium chloride that were once part of an ancient ocean.
Now this is where it gets really cool. Nature is unbelievably precise. As seawater evaporates, it doesn't just dump all its minerals out at once. No, it follows this super strict sequence. First, the carbonates drop out. Then, as it gets more concentrated, gypsum precipitates. And it's only when the leftover water, the brine, is about 10 times saltier than the ocean that our good old table salt, halite, finally decides to crystallize.
So, nature makes the salt. But how do we get our hands on it? Well, that brings us to the human part of the story, the harvest.
Humans have basically perfected two main ways to get salt out of brine. You've got the old-school artisanal way using the sun, and then you've got the super modern industrial way using heavy machinery. They're pretty much polar opposites, but both are incredibly good at what they do.
Solar evaporation is the classic method, the OG. Picture this. You channel seawater into a series of really shallow ponds. And then you just wait. You let the sun and the wind do all the heavy lifting. As the water evaporates, the brine gets saltier and saltier until these beautiful, glistening crystals just start to form, ready to be raked up by hand.
And the result of this slow, patient, natural process? Oh, it's incredible. This is exactly how we get those fancy gourmet salts like fleur de sel. They have these amazing textures and complex flavors precisely because they hang on to other trace minerals from the sea.
Now let's flip to the complete opposite, the modern industrial method. Here, brine is boiled inside these massive vacuum pans. So why a vacuum? Well, it's a super clever bit of chemistry. It actually lowers the boiling point of water, which makes the whole thing way faster and a whole lot more energy efficient.
And the salt that comes out of this industrial process, it's 99.9% pure. We're talking ridiculously pure sodium chloride. This is where your everyday, perfectly uniform table salt comes from.
Oh, and of course, we can't forget the third major method, just digging it straight out of the ground. For those huge halite deposits, miners can either go down there and crush the rock salt directly, or they can pump water down to dissolve it and bring the super salty brine up to the surface.
Okay, so we know where it comes from and how we get it. But why is some salt made of tiny little grains, while other salt forms these beautiful, delicate flakes? Well, to answer that, we need to zoom way in to the science of its shape.
The basic rule is actually pretty simple. Think of it like this. If the crystals have plenty of time to form in a nice, stable environment, no rush, they grow into their natural, perfect cubic shape. These are your big, chunky sea salt crystals.
But what happens if you crank up the speed, like way up, like they do in vacuum evaporation? Well, the salt doesn't have time to grow into big crystals. Instead, you get this massive, sudden explosion of countless tiny seed crystals, or nuclei, all forming at once. And that's how you get the fine grain of typical table salt.
And this is where the real artistry comes in. By carefully controlling the evaporation rate right at the surface of the brine, salt makers can actually coax the crystals into forming these incredibly light, crunchy, pyramid-shaped flakes that chefs absolutely go crazy for. It's all about manipulating chemistry to create the perfect texture. We've seen how it's made, But the final and maybe most important piece of the story is why it matters so much. And believe me, its importance goes way, way beyond your kitchen.
I mean, for centuries, salt was the main way to preserve food, period. Today, it's what keeps our roads safe to drive on in the winter. It's a fundamental building block for the entire chemical industry, essential for making everything from plastic to paper. Heck, even wildlife depends on natural salt licks to survive. It's everywhere.
It really is an unbelievable story. The journey of salt takes it from being just these invisible dissolved ions floating around in a drop of seawater to becoming one of the most foundational, critical, and universal materials in all of human civilization.
It makes you think, doesn't it? If a simple grain of salt has a story this epic, what other secrets are just hiding in plain sight, all around us, every single day? Thanks for joining me on this one.